Okay, so today we're looking at equations in two variables. First, we're going to look at ordered pairs as solutions. We're going to look at tables, and then we're going to look at graphing linear and nonlinear equations in two variables. So first, we want to recognize that a solution to an equation can be expressed as an ordered pair. For it to be a solution, it needs to satisfy the equation. In other words, it needs to make it true when the numbers are plugged in for the variables. All right, so let's look at the first example. So we're going to look at plugging in 1 for x and 4 for y. And so we're going to put 4 in the y and 1 in for the x plus 3. We get 4 equals 4, and that is true. So yes, that is a solution. All right, the next one, we've got 1/2 is x and -4 is y. So I'm going to show you, when you plug in the numbers for the variables, it's a good idea to use parentheses. So 2 times, then we're going to put 1/2 in for x, minus y is -4 equals 5. Okay, so if we hadn't used parentheses, this would have been a little bit messy, but it helps us to see what goes where. So 2 times 1/2, or in other words, 1/2 of 2 is 1, minus a negative is plus 4. Equals 5. That is true. So yes, that's true. All right, the last one, we're going to put -5 in for the x. So we've got -4 times -5 plus 5 times 1 equals 20. So -4 times -5 is positive 20 plus 5 times 1 is 5 equals 20. 25 does not equal 20. So this is not true. It is not a solution to the given equation. All right, so now I've got some here for you to try. Pause the video, give them a shot after I get the given ordered pair in there, because somehow that got missed, and I'm going to put that in here in just a second, and then you can pause it and try these problems. Okay, now I have the ordered pairs in there. So try these ordered pairs in the equations and see if they are solutions to the equation. Pause the video and come back when you're ready. Okay, here are the solutions. Where I've plugged in the x's and y's, I made them red, and the rest of everything else blue, so it's a little easier to follow that way. You should get yes, yes, and no. And if you didn't, take a look and try to find what you did wrong. Okay, so now we're going to look at making a table of solutions. And one thing to remember is that most equations in two variables have infinitely many solutions if there are two variables. So this is the first time we've looked at two variables. Both x and y are unknown, and they can both change. They're just related to each other through the relationship that has been created by this equation. So they're asking us to complete the table for this equation, y equals 2x minus 3, for x equals each of these four things, and we're supposed to find y. Okay, so that means you have to plug this in over and over again. So you're going to, luckily this is already solved for y, so we're just going to say 2 times -4, so that's the first one right here. And that's going to be 2 times -4 minus 3, which is -8 minus 3, which is -11. All right, the next one is y equals 2 times -2 minus 3, which is -4 minus 3, which is -7. The next one is y equals 2 times 0 minus 3, which is 0 minus 3, which is -3. And give myself a little more room here. And the last one, we're just going to plug in 2. Y equals 2 times 2 minus 3. And when you have the parentheses, so it makes it easier to kind of follow your work down through when you do these. And you get 4 minus 3, which is 1. All right, so we get -11, -7, -3, and 1. And so if you look at this, this is a linear equation, so these should go up linearly. So this one added 4, this one added 4, and this one added 4. So you should always get that when you complete a table. You should see a pattern. All right, so now it's time for you to try it. So give this one a shot and come back and check your work. Okay, so the solutions for the try it are shown here. Check your work. If you have any mistakes, go see if you can figure out what you did wrong and try it again. Okay, this next example does not have the x's filled out. It just tells us what's going on. And in fact, this time it says use y equals to make a table of solutions to this equation. So y equals 0, 5, 10, and 15. So I'm going to go ahead and put 0, 5, 10, and 15 in here. All right, so now it says to make a table of solutions. So we're looking for x. So the best thing to do here is just to rearrange this equation. So I'm going to come over here to the right. We've got 5x plus 2y equals 10. And we know what y is going to be each time. We want to know what x is. So we're going to solve for x. So we're going to subtract 2y from both sides. And we're going to get 5x equals 10 minus 2y. Then we're going to divide everything by 5. And we're going to get x equals 10 minus 2y over 5. And you can go ahead and keep reducing this if you want to, or you can leave it like this and just see what happens. So, so we're going to use this equation right here. And we're going to find it for 0, 5, 10, and 15. I'm going to do 0 and 5. I'm going to let you do 10 and 15. So we've got x equals 10 minus 2 times 0 all over 5. Okay, so 10 minus 0 is just 10 over 5, and that gives us 2. So this first one is 2. All right, the next one is x equals 10 minus 2 times 5 all over 5. So we get 10 minus 10 over 5, so that's 0 over 5, which is 0. So all my zeros are turning to circles because I've got the ink to shape on, so that's why I keep chuckling. Ooh, thought that was a diamond, didn't it? Okay, so the next two I'm going to let you do. So we've got 10 and 15, so try those. Of course, I'm not having you rearrange, but if you're doing this on your own, you would rearrange it. So pause the video and come back and see if you got the answers right. Okay, so the answer is shown here. And I just followed what I was doing up above. You should get -2 and -4. Okay, so this next problem is just a real-world problem with data from the PT Association. People with injuries need crutches. So an approximate crutch length in inches for an injured person who's t inches tall. So in other words, there's a formula to figure out what length crutches you need depending on how tall you are. So it looks like t is how tall they are, and L is the length of the crutches. So make sure you understand what you're doing before you get started. So make sure you understand both variables. All right, then we're supposed to fill in the crutch length that each of these height of people need. All right, so the equation, which I'm only going to write down one time down here, and then we're just going to fill it in over and over again. Times t plus 2. Okay, so that's going to give us the length. All right, so for 60, I've got 0.72, and you're going to need your calculator, times 60 plus 2. 0.72 times 65 plus 2. 0.72 times 70 plus 2. We're just going to keep doing this over and over, and you can use your calculator to make sure you understand how to put this in properly, because I have to say the biggest problem I see when people really do understand the material is that they're putting it in their calculator incorrectly. All right, so because this is order of operation and multiplication will happen first on your calculator, you can just put this in all the way across and then just hit enter. And you should get, when you put in this first one, you should get a length of 45 inches. And for 65 inches tall, you should get a length of 49. And then 52, 56, and 60. So we're going to put those up here in the table. 45, 49, 52, 56, and 60. And you know, you can just put this over and over again in your calculator and you don't have to write it down every time, but I wanted you to see it. All right, for B, it says, use a table to determine the appropriate crutch length for a person 5 feet 10 inches tall. So what is 5 feet 10 inches tall? Well, remember, feet is 12 inches. So you've got 5 times 12 inches plus the other 10 inches. So we've got 60 plus 10, which is 70 inches tall. All right, so now we're going to go look for the 70 inches tall, and that is this one here. So that means they're going to need a length of 52. So that would be the answer to this. So L would be 52 inches. Okay, next we're going to look at graphing linear equations in two variables. This is something you're going to be doing a lot in algebra. And it's just the beginning of graphing all sorts of different kinds of equations. So the graph of a linear equation is a straight line. So that's where the word linear comes from. It's a line. So here are the steps. We're going to start by making a table of values. It can be horizontal or vertical. I like using the vertical ones, but you can use whatever you want. Pick your x's to be things that are, so this is step A, things that are easy. So zeros are usually easy, ones are easy, negative ones are easy. Any numbers can be chosen, anything you want at all. So make them small and easy, and I would say choose at least 3. Okay, if you just do 2 and you messed up one of them, your line's going to be wrong. If you choose 3 and you messed up one of them, it's going to be obvious because it will be a straight line. It will not be a straight line. So calculate the y values for each x. Then the table here shows the points. These are the coordinates, -1, -2, 0, 0. You're just going to plot those on the graph and then connect them with a line with arrows on either end because it goes forever in both directions. And this is going to be the line of the graph. Okay, so now we're going to try it. So I want to show you how to graph this first one, and I'm going to do the harder one, although the second one is going to need to be rearranged. So, but this first one has a fraction, and I want to give you a couple of hints on that. So picking your x's, that's the first thing you need to do is pick some x's. But I noticed that I'm taking half of the number, so I think I'm going to only use even numbers. Because if I have half of 1, I get 1/2, and then I have fractions, and it's no fun to deal with fractions. So it doesn't really matter what you pick, so pick easy things. So I'm going to do some negatives and some positives with 0 in the middle. So I'll say I'll have 0 about right here. X I'll do -2 because I only want even numbers, and then I'm going to have 2 and 4. Okay. So y equals 1/2, I'm going to put my first number in, of -2 minus 1. So 1/2 of 2 is 1. So 1/2 of -2 is going to be -1. So we get -1 minus 1, which is going to give us -2. All right, the next one is y equals 1/2 of 0 minus 1, which is just going to be 0 minus 1, which is -1. All right, the next one is y equals 1/2 times 2 minus 1. So 1/2 of 2 is just 1, minus 1 is 0. And the next one is 1/2 of 4 minus 1. 1/2 of 4 is 2, minus 1 is just 1. Okay, so we've got 0 and 1. So now we have all our points. So -2 is here. 0, -1 is here. Be careful with the coordinates that have zeros. People generally, very commonly, get those messed up. So remember, x means I'm moving left or right. So if x is 0, you don't move left or right. All right. When x is 2, y is 0. So y is 0 means I don't move up or down. So I stay right here. And then 4, 1. Okay? And so then I would take a line and I would draw it through, that did not work very well. It didn't let me put my line through it. But anyway, I would put a line right through those lines, those dots there. And a ruler does make it easier. All right, so now I'm going to have you try x plus y equals 4. So let's come down and do x plus y equals 4. So I'll rewrite it for you. So the easiest thing to do, of course, is to solve for y. So go ahead and solve for y first, and then figure out your x's and plot your points. And I'm going to stop and put everything in, pause the video, and try to do it yourself. Okay, so I had a little more time and I made my graph a little bit nicer this time with a real line, but notice there's double arrows. There's an arrow on each end. You're just going to solve for y equals 4 minus x, and plug in some numbers. I chose -1, 0, 1, and 2, and I got these y's. Whatever you get, you should get the same line. So you might have gotten different points, maybe some points down here, some points up there, but it will be the same line. Okay, so we're looking here at the standard form of a linear equation. Standard form looks like this right here. Standard form, ax plus by equals c. So then you can figure out what a, b, and c are. So c can be 0, but it might not be. It might be a number. So if we put y equals 2x into standard form, I'll come up here so I have a little bit more space. So y equals 2x. So I'm going to subtract 2x from both sides, and I get -2x plus y equals 0, and in this case then a would be -2, b would be 1, and c would be 0. So that's in standard form. Okay, we kind of already saw this because I had it in an example, but we're going to solve standard form for a variable so that we can create a table and then graph an equation. It makes it much easier to graph it if you put it in what we call slope-intercept form, which you'll learn later. But so this is 4x minus 3y equals 12. And we are going to solve for y first. So they're asking us to graph it by solving for y first. So we are going to subtract 4x from both sides, and we get -3y equals -4x plus 12. Generally we have the x's and y's before the numbers, before the constants. Now we're going to divide everything by -3. You could also do one big long line, but it's a little less obvious when you need to solve each individual one. So we've got y equals -4 over -3 is just 4/3. 4/3 x. 12 divided by -3 is minus negative, so I'm going to just say -4. 4/3 x minus 4. Okay, so now we have to find some x's to plug in to solve this. So I'm going to do -3, because I see here that I've got a fraction that when I do 3's, it's going to cancel out. It's going to divide out. So I'm going to use 3's. So I'm going to use -3. I'm going to use 0, and I'm going to use 3. I'm just going to do 3 points because those are the simplest. I could do 6, but it kind of goes off the edge of the graph. So, but we could check it with 6 and just see if it looks like it makes sense. All right, so we've got 4/3 times -3 minus 4. So 4/3 times -3, so the 3's are going to divide out, and I get -4. Don't forget this negative right here. Don't lose that. -4 minus 4 is -8. So -8 goes right here. The next one we're going to put in is the 0. So we've got 4/3 times 0 minus 4. So remember, we're using this equation right here that we have rearranged. Okay. All right, so we've got 0 minus 4 is -4. And then we've got 4/3 times 3 minus 4 is going to be, the 3's are going to divide out, and we've got 4 minus 4 is 0. All right, so we've got some things going off the graph here, so we may not have been able to choose a -3, but anyway, we've got -3, and then we go 1, 2, 3, 4, 5, we'll say 6, 7, somewhere down in here. All right, and then we've got 0 and -4 right in here, and then we've got 3 and 0 right in here. And that looks like a line to me. We could choose a 4 and see where we end up, so I'm going to plug in 4/3 times 4 minus 4, and I get 16/3, which is minus 4. So 16/3 minus 4 is going to be 16/3 minus how many thirds is 4? 4 is 12/3. So that gives me 16 minus 12 is 4/3, or 1 1/3. Okay, so that helps me when I graph. So this one we've got 4 and 1 1/3. So I'm just checking because one of them went off. So 1 1/3 is about right in there. So then we're going to draw a line. Okay, so I drew my line, and I've got, the one I had down there was just a little bit off. So I drew a real line using OneNote line feature. Put double arrows on the ends, and that's what it looks like. So this is the graph of 4x minus 3y equals 12. Okay, now it's time for you to try one very similar to the one I just did. So remember to rearrange and solve for y first, and then pick some points and graph your line. Okay, so I chose -3, 0, and 3 because I saw that I had, when I rearranged this, I got 2/3 x plus 2. So I wanted the 3's to cancel out. So I chose factors of 3, and I got this graph right here. So even if you chose different numbers, it should look the same. Okay, the last topic is graphing nonlinear equations in two variables. So sometimes you're going to get something to graph that's not a perfect line. And remember, one of our big clues to this is that we have a squared, or it's in the denominator, or it's under a radical. So we've talked about that in the past, and that is how you know that you're going to have a nonlinear equation. Okay, so first what we want to do is we want to pick some x's. So we've got a graph that only goes up to 5. These sometimes take a little bit more, so you can get the true shape of the graph itself. So I'm going to say we're going to do -2. This just keeps jumping around. We're going to do -2, -1, 0, 1, and 2. Let's try that. So we've got -2, -1, 0, 1, and 2. Notice I left 5 spots this time because it does take a few more to get the shape, and even sometimes that's not enough. And you want to try to be symmetrical on these so that you can kind of see what's going on. So the first one is y equals -2 squared. Remember, when we square a negative, it's like saying -2 times -2. So the negative goes away. Be careful. I see a lot of people missing those. So we get 4. All right, y equals -1 squared is 1. Y equals 0 squared is 0. Y equals 1 squared again is 1. So you're going to see something symmetrical happen here. And 2 squared is 4. So we get 1, 0, 1, and 4. So this is going to be symmetrical around the y-axis, but we get -2 for x. I'm going to do this in a different color. -2 and 4. And then we get -1 and 1, 0, 0, 1, 1, and 2, 4. So this is actually what's called a parabola, and this is because this is a quadratic equation. So you'll see some of these, and you'll also see absolute value, and you'll see square roots and things like that. All right, so why don't you give this one a try? Oh, here's an absolute value for you to try. So make sure you try 5 points and make it symmetrical around the y-axis. Okay, so this is probably your first look at an absolute value graph, but this is what it looks like. It has a sharp point at the bottom, and it's a perfectly straight line going in both directions, symmetrical about an axis in between. In this case, it's the y-axis. So that's the end of this video. Thanks for watching, and we'll see you in the next one.